Okay. So the SOL, standard of learning, which is Algebra 2.6, that is pretty much all these things right here. And honestly, what it's about is transformations. Transformations of functions, of graphs of functions. Now, the cleanest example we have of that is the absolute value function. So that's why you always start this topic by talking about absolute values. But in the end, we're supposed to know how to do the same thing with other kinds of functions: square roots, cubed roots, rational, polynomial, exponential, logarithmic. In every case, it's this, pretty much the same thing. I mean, if you're taking a foreign language, especially if you're taking like Spanish or French or something like that, you learn how to conjugate the verb. And then if somebody gives you a new verb infinitive, right, then you just do what you do when you get to that kind of verb. I mean, you just do it. Well, that's kind of the parent functions of all these things are like the infinitive of the verb, and the transformations are all the different conjugations that you're going to do. But it's going to be the same thing. You got to see it as a more general topic than just, oh, this is about absolute value, because it's not. Okay. So, again, we're not dwelling on this, but the absolute value function has the shape of a V. Okay, it has the shape of a V. We know what the effect of an absolute value is. Absolute value takes whatever's inside and it turns it positive. If it's already positive, right, then you get, all the points in this line are 1, 1, 2, 2, 3, 3, 4, 4. It's the same thing, right? They're all connected with a line, and that line has a slope of 1, right? When x is negative, then the effect of the absolute value is to switch the sign, to flip it positive. So you get all these points. Negative 1, 1, negative 2, 2, negative 3, 3. Right, and the slope of that line is negative 1. And put them together, you got a V. So what's the shape of an absolute value? It's a V. So if you're asked to graph absolute value, got to have a V, or else we miss the main point. Just like a parabola, a absolute value, the V has a vertex. Right, the vertex is the point of the V. And what we mean by parent function, it's like the most basic example of the absolute value, which is f of x or y equals the absolute value of x. There's nothing else with it. It's just the plain absolute value. That's what we mean by a parent function. And I should say that just like with a parabola, that V is symmetric, right? It's exactly like a mirror image on the left as on the right. So they've actually graphed, just to show, the one thing they didn't put in there that we put in with a parabola was an axis of symmetry. But there would be a line of symmetry that goes right through the middle of that. And you would expect if there's a point that's 2 to the left, 2 to the right, there should be a point that's 2 to the left, right? 3 to the right, 3 to the left. It's got to be symmetric. Yeah. No, because it'll move around. Just for the parent function, it's here. But what we're going to be doing in class today is we'll be moving this left and right and up and down and flip and stretch and shrink and all kinds of things. So the starting point is the absolute value is a V with the vertex at the origin. The slope on the left is negative 1. The slope on the right is 1. So we really only consider like 3 different numbers that we might throw into the mix here. You could multiply the absolute value by a number. That will change things. You could add or subtract a number from x. You could add or subtract a number after the absolute value. Each one will shift the graph in a different way. Now, we saw these letters before. When we were doing quadratics, those are the coordinates of the vertex, and they are the coordinates of the vertex here too. It all works the same. Oh, okay. Forgot about that. Okay, so what we're gonna do now is you're gonna use your calculator, and we're gonna play around with putting numbers here in the place of A, H, and K, and see what happens to the graph. We're good? Nate, you're good? So first, you want to turn on your calculator. Remember, because you could have other things in there, and it's better if you just start from scratch. How do you clear the memory in your calculator? Second plus 712. Don't forget that, right? If you have errors on the calculator, sometimes you just have to clear the memory and try it again. So look above the plus, it says mem. So second plus 712. That's what we're going to get to next. Okay, second plus 712. Okay. So if I go to the y equals, right? And let's say, you could see what I did, okay? There's a few things I want to show you here. First is, on the first line, I've got the parent function, absolute value of x. Okay, so it's, where do you find absolute value? There's at least 3 different ways you can get to absolute value. One of them, hit the math key, and then arrow over to num, and it's the first option. You see it? So math num 1. Another way that you'll probably find yourself using, actually, is you go alpha, the green key, and then you hit window, and it brings up 5 functions. The first one is absolute value. So alpha window 1, that'll get it for you. And then the last one, I'm going to put it back up here, is, if you go down on the 0, it says catalog. So if you go second 0, absolute value is actually the first one in the list. So there, it's very easy to get to in that list too. Under catalog, you can find anything. If you can't find it anywhere else, go to catalog. So I'll just use that. Not sure what this is. Okay, so y equals, okay, just a second, alpha, window, 1. Okay, x is this key. Do you see my cursor? Right, it says x, comma, t, comma, theta, comma, n. So you hit that. And now how do you get outside of the absolute value symbols? Right arrow. Just right arrow out of it. Okay, that's it. And then enter. It gets me down to the second line. Now, I want to see what happens when I add a number after the absolute value. What kind of a shift in the graph is that? So I'm going to go, I'll put the absolute value of x, I'll get out of the absolute value, and I'll put a plus 2. So where am I? Alpha, window, 1. Come on. My calculator. Try this again. 1. Okay, and here I put my x, and then I get out, and I put a plus 2. Now this is a thing that you don't have to do, but I like to do when I'm comparing 2 graphs. I kind of like to know, well, which graph came from which equation. So if you scroll all the way over into the left margin there, and then hit enter, it'll turn the line, which is right now kind of a thin line, into a fat line. And you'll be sure which graph came from which one. So scroll over so that the cursor is blinking in the left margin, then I hit enter, and it turns into a fat line, right? Okay, now I'm going to hit graph. Hit graph. So the light line there, this line is the parent function, and then this fat line is the plus 2. Now, if it's hard to see that, okay, something else that you should know how to do is you can zoom in. That button right there will let you zoom in on that. I mean, just hit zoom to and enter. Zoom to enter. Now, this is what I did too. You know, that was my first thing, and I thought, I don't like it. It's too high up there. I can barely see the plus 2. So I wanted to move my window so that it was just a little bit higher. Okay, well, that's why you got that window key right there. So if you will, hit the window key, and then it'll let you put, like, what are the x value, between which x values do you want the graph to go, between which y values do you want the graph to go. Now, the x values are okay, so let's change the y values. Maybe we'll go from a y min of -1, and maybe I'll go to 4 y max, and then I'll hit graph. And now it's shifted the whole thing up a little bit. So now I can see it a lot better. Okay, what does it look like it did to the graph of the function by adding a 2 after the absolute value? How did it shift? Up 2. See that? That's a tick mark. Up 1, up 2. So by adding a 2 after the absolute value, it moved the graph up 2. Now, every time I did it, I think I was switching the window around quite a bit. Here's another thing you need to know, because if somebody's been using a calculator before you and they've got the window someplace and you don't know how to get back to just the regular old viewing window, then you could do zoom 6. Zoom 6 will bring you right back to the middle. Zoom 6. There, that's how we started. So if somebody leaves you in a place you don't understand, then hit zoom 6. Okay, so we just playing around. We added a 2 after the absolute value, and it moved it up 2. What do you think would have happened if I would have subtracted 2 after the absolute value? It goes down 2, right? It's just adding and subtracting to the y values. So yeah. So the first thing is, if you add a number after the absolute value, that's a vertical shift. Plus means up, minus means down. Not just for absolute value, but for any kind of function. Yeah, I mean, if this number is a positive number, that means you're going up. If it's a negative, if it's a minus a number, then it's down. We good? Here we go. So now let's see what happens if we add or subtract inside the absolute value. So I'm not going to redo it with my calculator now because I already did it and copied it here, but line 1, I've got absolute value of x. Line 2, I've got the absolute value of x minus 2. Okay. Now, you might guess that's going to be horizontal because the other one is vertical. This must be horizontal, and it is. But if you had to guess, which direction are you moving when it says minus 2? You're probably going to guess that means go left, and it doesn't. Look what happened to the graph when you did a minus 2 inside. It went to the right. That you got to remember that. A minus inside means right. A plus inside means left. Now, why is that? I mean, Remember, the vertex of the parent function was 0, 0. So we're trying to figure out, it's going to go horizontal, but where is the vertex going to go? Well, in order to have y equals 0 here, you got to have the 0 of that factor, which is positive 2. Right? When you put in a positive 2 there, you get your 2 minus 2 is 0, and then y equals 0, and that's why the vertex hits the x-axis at that point. It may seem counterintuitive, but that is the way it works. And you could prove it to yourself, right? Just put it in the calculator and see what happens when you do a minus inside. So my inside, if it says minus a number, that means it's going right. If it's plus a number, that means it's going left. We good? Okay. Okay, so now, what if you have more than one shift? By what we've already learned, what's that minus 1 going to do to the graph? 1 to the right and 3 down. So if you're sketching this thing, then all you have to do is go 1 to the right, 3 down, right? That's the vertex. We know that it's a V, and on one side of the V, it's a slope of -1. On the other side, it's a slope of 1. So I can sketch the sides of the V like this. That's terrible. Undo. Let me use the line instead. Something like that. And that was close enough. So there's my V. Now, if you remember when we did the vertex form of a parabola, right, it was x minus h squared plus k, then we would have, again, because of the minus in the formula, we would have said that means the vertex is +1, -3. So +1, -3. So you can think of these like coordinates of the vertex, or you could think of them as horizontal and vertical shifts. Either one. You know, the only thing is that when we use it with other functions, not every function's got a vertex. In fact, quadratics and absolute value are like the only two. So probably better to think of them like shifts. Okay, now we're going to see what happens to the graph of the function if you stick a minus in front. I mean, if you remember, I was using an a as the constant in front. So in this one, a is +1, and this one, a is -1. What does it look like happen to the graph? How would you describe the relationship of this to this? Upside down, flipped. The proper technical term, it's reflected in the x-axis. Boom. Right? Reflected in the x-axis. It's the same V. You know, the only thing that's changed now, the vertex is in the same spot. Now the left side of the V has got the positive slope, and the right side of the V has got the negative slope. I think the next slide will show you that. And you could say flipped. Most of the time you just say flipped, but you got to say flipped which way. Flipped in the x-axis. Flipped across the x-axis. Because you got a minus sign in front, not a negative. Okay. So how would you reflect in the y-axis? I mean, the one we just did, it flipped it across the x-axis. How would you flip across the y-axis? By putting the minus inside the absolute value. But what would that look like if I flipped an absolute value v across the y-axis? It's the same thing, right? So it's not really a very good example to show flipping across the y-axis with absolute value. It's better to show like this, and this is a function that we'll get to soon, square root, right? The square root function, which is this is the parent function of the square root of x, right? If I flip that across the y-axis, then you definitely see it, right? And you're doing it again by putting a negative in front of x inside the function. Need some help, Sean? What's that? What are you trying to put in? Square root? Or square root? Second x squared. What's that? Good. So you still have absolute value there, and now that square root, you don't have the negative x inside. Second square, right? X. 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 That's not X.
I always just went down here.
Okay. No, X is here. Use this. Then you arrow down. Okay, and now put in the square root of negative X. Negative. Graph. There's the one. There's the other. Okay. So the last thing we got to figure out is, okay, we know that what happens now if you have a negative a, but what happens if a is not 1 or negative 1? Okay, so this is comparing the absolute value of x with 2 times the absolute value of x. Right? Absolute value of x, 2 times the absolute value of x. So what did it do to the graph? By multiplying it by 2, it actually made it narrower, right? It actually, what it's doing is it's making the y values go up faster, right? Which is called a vertical stretch. You don't have to. I mean, I'm just doing this so I can show you those slides that say what the general transformations are. Now, one thing about these here, these next two, right, multiplying by a number whose absolute value is bigger than 1, and the next side will be absolute value is less than 1, it's actually changing the shape of the graph. Everything else we did didn't change the shape of the graph, right? It moved it around, it might flip it. But, I mean, you did in geometry, you did what's called translations. And that's what everything up to now has really been a translation. We've moved a shape around. I think maybe in geometry you use this terminology too. Pre-image and image. Do you remember using that in geometry? Okay, and that's what it was. And in geometry, you know, we did that. A lot of the point of that was that when you do translations, no matter how you move them around and everything, you get a congruent shape. It doesn't change angles or side lengths or anything like that. It's a congruent shape. This is changing shape, right? And this definitely then falls into the category of transformation, not necessarily a translation. But, you know, you can hear both of those words probably used incorrectly sometimes too. So multiplied by a number bigger than 1, and it stretched it. Okay, now I'm multiplying by a number which is less than 1. It's actually negative, right? So I'm comparing the graph of negative absolute value of x, which is this v, to negative 1/2 times the absolute value of x. So here's the v before it was multiplied by negative 1/2 or 1/2, and now notice this line is in between that v and the x-axis. So it's actually it's moving away slower. It's kind of flattening the thing out, which is called a shrink. So if the absolute value of a is less than 1, it's a vertical shrink. Last year, the book we used, they used vertical stretch, but then they used a vertical compression for this one. But this book doesn't do it. Because it's like pushing it closer to the x-axis, you know, it's kind of flattening it out too. So those are like, I think that's everything in terms of like all the different ways we can transform the graph. There's one other, but I'll mention in a second. So the a, if the absolute value of a is greater than 1, it's a stretch. If the absolute value of a is less than 1, it's a shrink. If a is greater than 0, it opens up. If a is less than 0, it opens down. You know, and this terminology here, that's exactly like we did with parabolas too, right? Ax squared plus bx plus c, and the a told you, does that u parabola shape open up or down? It's the same thing here. We good? So put it all together, okay, and we can say this is, the h is horizontal, k is vertical, the a is stretch, or shrink or up or down. There's one other thing that could make this like one step more complicated, which I don't see it in this book yet. And honestly, I don't think they usually don't throw this at us. But what if you had something like f of x equals absolute value of 2x minus 3? What would be the shift now? I mean, because it's a minus 3, you may think, well, 3 to the right. But it's not 3 to the right because of that 2, which is in front of the x. Again, remember when it shifted to the right, it was because that number was the 0 of this factor. Well, what's the 0 of this factor? What value of x makes this equal 0? 3 halves, right? So it's actually only shifted 3 halves to the right, not 3 to the right because of that 2. Yeah. Horizontal. H-O-R-Z-V-E-R-T. Good. Come on. Okay, let's go. So, graph. So it says graph this function and compare it to the parent function, y equals absolute value of x. Okay, again, the parent function is at the origin. So let me put that in. Right, that's a v that looks like that and that. Okay, now, what are the shifts that you see in this function? Plus 4 inside means left 4. Minus 2 outside means down 2. Is it going to open up or down? And it's a V. So it's a V that opens up. It's 4 left, 2 down. Four left, 2 down. There's one side of the V, and there is the other side of the V. I messed all that up. Darn it. Close enough. Again, you could think of that as a shift to the left and down. You could think of it as the coordinates of the vertex, -4, -2. So here's yours. Graph that one. Graph the parent function and then graph that on the same background. So that's my artist rendition. See that? So it should have gone 2 to the right, 5 up. There's nothing, the A is 1, right? So it's still the slope on the right side is 1, the slope on the left side is -1. We good with that? Prayashi? Okay? So now let's try to graph this one. And I'm not going to graph the parent function. I'm just going to graph this. So what does the negative tell you? It's opening down. And the 3? Yeah, it's going to stretch it out, right? But again, the way I like to think of it, just especially if you've got a nice grid there to look at, what is going to be the slope of the left side of that V? Positive 3, right? And what is going to be the slope of the right side of the V? Negative 3. So the vertex has not been shifted. There's no adding or subtracting of anything. It's just being multiplied by 3. So I'm going to make it go. This is where the lines come in handy, you know. See, I just drew that line so that its slope is up 3, right 1, up 3, right 1. Okay, and now I'll make a negative 3 on that side. Yep. There we go. That's pretty good. So that's a stretch. We're ready for the next. Okay, the next one is for you, I'm sure. Graph 1/4 times the absolute value of x. So, you know, it should have been a slope of positive 1/4 on the right, negative 1/4 on the left. The vertex wasn't shifted. No adding, subtracting, anything like that. Now, if you look in the book, how they graph them, they describe something that's a little different. But kind of, you know, when we did the graphs of parabolas, this is probably a little closer to what we did with parabolas. And we are going to do some parabolas in a second. But you could see that they didn't look at those two numbers as shifts. They looked at them as the vertex, right? That's a vertex of 1, 3, 1, 3, 1, 3. It opens down because it's negative. Now they're saying plot another point. So they know the vertex, plot another point. And they said such as, you know, what does it say when they just say such as? They picked it. You know, you could pick something else. If it, you know, the question is not why did they say 0, 1. They just said, you know, they just picked a point. Now, that's not just any point. What point is that? So y-intercept, right? Because x is 0, y is 1. So they plugged in 0 here, and then they calculated the y. So they got this point right here. That was their step 2. Oh, actually, not quite done. Now, since it's symmetric with respect to the middle, if the y-intercept is 1 to the left, then there should be another point 1 to the right. And now with those 3 points, draw on your parabola, or your V. So try to do that one. Sketch the graph. So what is the shift with that plus 1? Left 1. What about the minus 2? Down 2. So that's telling us the vertex should be here. Does it open up or down? Down. What's the slope of the sides of the V? 3 and negative 3. -1, -2, right there. It opens down because that's negative, and the sides of the V should have a slope of 3 and -3. What are we up to here? 22? Almost done. So both of these graphs are supposed to be absolute value of x plus 3. What'd they do wrong? Caitlin? Yeah, they're both, the correct graph of x plus 3 inside absolute value would have been 3 to the left. Yeah, this is 3 to the right, that's 3 up. At least they didn't give us 3 down too, right? But the correct would have been 3 to the left. And then multiple choice. Which one of these is that graph? Which two can you throw out right away? Well, it opens down, so it has to have a negative in front, right? So A and B are out of there. So the only question now is, are the sides of this V, do they have a slope of 2/3 or 3/2? I mean, just try to see if you can pick out like the intersection of grid lines here, like from here to here is up 3, right 2, 3/2. Yeah. So that should have been D. Oops, don't need that. Need that and put there D. Okay, now this is a parabola actually. This is a quadratic, but you can graph it pretty close to the same way we graphed the absolute value V. We actually already did this, right? And so just doing what we did before, what is the vertex of this? Or describe the shifts, that'll get you to the same place. Plus inside means +2 in, Kaylin? Left 2, the +5 means? Right, so it'll be left 2, up 5, right? So the vertex of this thing is going to be right there. Is it going to open up or down? And it's going to open down. Yeah, because now it's a quadratic, it'll be a parabola. The shape won't be a V, it'll be a U, right? So I can put in my vertex, -2, +5, right there. And then I do need a point. This is where their method of doing that before wasn't bad. You know, we do need a point, and the y-intercept is now a bad point. What would the y-intercept of this be? I mean, how do you find y-intercept? Substitute x equals 0 and solve. What do you got? Right? You say y of 0 is kind of like function notation. -1/4 times 2 squared plus 5, which is -1 plus 5, which is 4. Okay, so this has a y-intercept at 4. Okay, use symmetry now. What other point could I put onto that graph? Right, what's the other point? The y-intercept is 2 to the right, 2 to the left, -4, +4. That point right there. And that's enough points there. Almost done. There's one for you. You try that one. Yeah. Right one, up 5. Right one, up 5. No, what it means is it's opening down. No, because this thing is shifted, right? If it's at the origin, then when you just put a minus in front, yeah, it flips it across the x-axis. But if it's already been shifted up here, instead of opening up there, it opens down. So it's really with respect to that line, not the x-axis. And the y-intercept, y of 0, like f of 0, is 4. So that's right there, and then use symmetry to find another point. That's it. So basically, we're supposed to be able to do those transformations on other functions. This is just the starting point. Absolute values, square root, cube root, rational, polynomial, exponential, logarithmic. So the main thing is don't think of them all like they're different. It's not. It's doing the same thing with everyone, right? Less things to memorize if you think of it that way. And that is mercifully the end. So these homework problems these are all absolute value problems. These are actually quadratics. Think of them like transformations.